Hey folks, how's it going? This is Mr. Murray coming to you with a Do Now video for Course 2 Honors. This is going to be our Do Now for 3/19/2020. So we just came off what I felt was a pretty good Google Hangouts conversation about what we've been doing in class. I really appreciate your persistence. You stuck it out. We had a really good turnout, and it was almost the full class, and we were able to go for about a little bit longer than a typical class session would go. And so that was really great, and it seems like a lot of us are doing pretty well with the law of cosines and the law of sines. If you're not in that situation, that's completely fine. Today is going to be kind of a day to get caught up and to kind of make sure we're in a good place to start moving on. But please make sure you try out this do now right here. So what we're going to do is we're going to solve this triangle. I'd like you to round all intermediate answers to 3 decimal places and all final answers to 1 decimal place. So what this means is that with regard to the angle, like if you figure out any angle or side, if there's 3 decimal places, write down all 3 of them so you can use it for one of the other calculations if needed. But when you give me your final answer, you only put 1 decimal place in there. So here's my example. Let's say that I found that I had some angle F. And angle F was about equal to, I did an arc cosine or an arc sine or whatever you're supposed to use here, and I got 36.123 degrees. My final answer, I'm going to report 36.1, but for any other calculations that rely on F, I'm going to use the full 36.123. Okay, so please take a moment, attempt this problem, or rather, I guess, pause, attempt this problem, and then when you're ready, unpause, and I'll show you how to solve it. All right, here we go. So again, hopefully you were able to figure out by this point that this is going to be the law of cosines. And that is probably what I'm going to want to use here. I do want to make sure that I have an exact answer. I do have angle, side, angle information rather than angle, angle, side, or etc. So I'm going to go ahead and I'm going to see if we can solve this. Notice though, why can't I use the law of sines? So what I want to figure out? So if I was going to figure out this side, right, I would need one of the other 2 angles, because to do law of sines, right, let's say I want to know this side right here. So to be precise, I'll head down to my answers. Let's say that I'm going to call the triangle A, B, C. Now, if your numbers turn out different from mine as a result, like if your A isn't the same as mine, as long as you can get the same 3 angle measurements and the same 3 sides as me, don't worry about it. And in the future, for any test or quiz or assignment, I'll make sure to specify. And otherwise, if I don't, then let me know and I'll make sure that that's clear. So I can't use the law of sines. And by the way, if you need to, please use the Wolfram Alpha if you're having any trouble with the calculations or you don't have a calculator at home. So I can't use the law of sines because let's say I wanted to figure out little c using the law of sines. I would have to know one of the other 2 angles. For example, I'd have to know this angle, so I could do sine b over 20 is equal to sine 105 over c. So there's not enough known information. And for the same reason, it's going to be difficult to figure out the angles. In theory, it's not impossible, but the problem is, how would I figure out this angle, big B, because I don't have the information for this side right here. So this indicates why the law of cosines is sometimes required, because the law of sines will not work in every situation. So let's start by filling in what I know. I know that C is 105, that was given. And if you label the triangle differently, that's fine, as long as you got that one of them was 105. I know that little a, I'm choosing to call this big A, so I know that little a is 15, and I know that little b, what we're going to call little b, is 20. So that actually enables me to find little c because I know that c squared, so I do the other two, I square them, 2ab cosine of c. That is the law of sines. And if I want to know a, then it's a squared equals b squared. So it's basically these letters here, the little letters are the other two little letters, and the big letter represents the side, the angle that's opposite from the side you're trying to find. Okay, that's more or less how this works. So again, I'm going to try to make the formulas available to you so you don't have to memorize them. But if you get the gist, it will save you time. So let's plug in. C squared equals a squared plus b squared minus 2ab cosine 105. So let's figure this out. So on my calculator, I'm going to do 15 squared plus 20 squared minus 2 times 15 times 20. I have to hit manually cosine 105. 780. And we're going to use 3 decimal places. So c squared is approximately 780.291. And I'm going to plug that in because remember, the more decimal places you use, the less error you get. The less future error relies on past error, the more accurate future error is. Okay, you don't think of error as accurate, but we'd like to be as accurate as possible. Okay, so that's approximately C. Don't forget to square root. Okay, so what I'm going to report for C is 27.9 because I'm only going to use one decimal in my final answer. But in the event I need to use C for any other reason, this is the number that I'm going to use. And why we're doing this is because now I need to find A or B. In this, I'm going to show, just for time's sake, I'm going to show how to find A. If you found B, the process is basically the same, except with different letters. Okay, so I'm going to find A using the law of cosines, big A, and then I'm going to find big B by thinking about the fact that the angles have to add up to 180 because it's a triangle. So what I know is I know that A squared equals B squared plus C squared minus 2BC cosine of A. And what we learned by the law of cosines is that cosine of A equals A squared minus B squared minus C squared over negative 2. So this should be, negative 2 BC, right? We got that by getting A alone in the law of cosines equation. Okay, so this is where the 27.934 comes in. So what we're going to do is, we know the cosine of A in this particular case is 15 squared minus 20 squared minus 27.934. So we use all three to minimize our error. 2BC. So again, and I know I showed you the other way in the Hangouts. I'm going to stress again finding the numerator and denominator independently and then doing the final answer in the end. And just for safety, I'm actually going to put the 934 in parentheses just to make sure it's absolutely correct. Okay? So cosine of A is approximately negative 9.5, or rather 955.308. Let me do the bottom. Negative 2 Okay, so the bottom is negative 1117.36. So what that means is that A is approximately the inverse cos of this stuff. 955,308 negative 1117.36. I hope you'll forgive my handwriting here. So I'm going to do this. So I'm going to do second cos negative 955.308 negative 1117.36. And what I get is A is approximately 31.244 degrees. Now, you might have gotten an answer that's slightly different than mine if you solve for the cosine. And the reason that might be is, one, I could be wrong, possible. Two, more likely, it could be that you did different rounding. So, for example, when I did the 955,308, if you left the 356 in there for the purposes of your calculations, I'll show you what the difference is. So let me go back and I'll show you. Let me get out of the mode view. So it is good I'm in degrees. So I'm going to pull this back down and I'm going to do an insert to show you what it looks like if I had kept all of the decimal places in that answer. So I'm going to go second del, which turns into cell instead of del, and then I'm going to add 3, 5, 6 to get the full decimal place from the previous answer. Okay, in essence, you are going to end up getting something slightly different. It's not going to make as big of a difference here. Okay, but if you thought, here's another scenario. What if I had just rounded to only one decimal place? So let me pull this. So one decimal place would give me a similar answer, 244. Okay. Interesting. All right. So I'm going to report out for A. For the purpose of reporting, we're going to use one decimal place. We're going to say A is 31.2. And in this case, it didn't make a huge difference, and we got lucky. But please heed my warnings about rounding. You want to minimize rounding as much as possible. Don't go crazy and use every single digit the calculator gives you, though you can if you want, but don't feel you have to. But you do need to save a decent number of places. You certainly can't round off to the nearest whole number unless you're specifically told to do that. Okay, so look for directions with rounding, but again, for intermediate answers or answers that help you get other ones, I would get into the habit of doing 3 decimal places and then either maybe look to the problem to tell you how many decimal places for the final answer, or ask me. Now for B, well, we know that C is 105. We know that A is 31.244. So we get 136.244 is the sum of our other angles. So we'll come over here and do 180 minus 136.244. And what I get is 43.756. So I'm going to report 43.8. You'll notice that these add up to 180 because this is 79, or rather 74. So 74 plus 105, these just the whole numbers is 179. And these kick in another whole angle for 180. And this is our final solved triangle. So we say A is 31.2, B is 43.8, C is 105, A is 15, B is 20, C is 27.9. Remember that you could have gotten a slightly different answer if you solved for big B and then did a similar method to solve for big A. But little c, there's only one way to do that, and that's the law of cosines. Okay, so I hope you found this video to be helpful. Please make sure you understood where I got all of these answers, and if needed, review what we've done this week on the law of cosines. But again, thanks so much for all your hard work. Keep it up. Keep a positive attitude. Don't forget to love math. And remember, you can do it. Thanks so much, folks. Have a wonderful day. Take care.